So we're going to perform some equilibrium on this beam. We're going to apply equations of equilibrium, and we're going to choose them in a fashion that creates one equation, one unknown whenever possible. Right? And we have three unknowns that we need to solve for. So again, we have enough equations of equilibrium. We are going to have three that are linearly independent. So I'm going to create two different maps to do this. We're going to have a little plan as to how we're going to solve for these unknowns. And I'll do this with two different schemes. So the first scheme, we're going to sum a moment at point C, which is sitting on the left end of the beam. Right, that'll give me one equation with just F1 in it. Next, we are then going to sum a moment at point B, which is at 6 meters on the beam. And that will give me the ability to solve for F3 with, again, one equation, one unknown. And then, although a little less challenging, we're going to end up then summing forces in the x direction, and that'll give me the ability to solve for F2. Right, and we'll do another scheme. Again, you have many different possibilities as to how you want to go about solving for these unknowns on our beam. So I'm going to present scheme number 2. Right, and this is going to be actually done with nothing but some of the moments equations. And so we're going to spin a moment at B to begin. That's obviously going to give us the ability to solve for F3. We're going to spin a moment then all the way on the left end of the beam over what we've called point A. That would give me an equation that just has F1 in it. And then we're going to choose a point above C, just somewhere off the beam, and at this point our one unknown would be solved for F2. So as I'm demonstrating here, the approach that you decide on to solve for your unknowns, right, could vary. Not one answer is correct here. Again, you most likely would like to try and approach this such that whenever you apply an equation, you only have one unknown.